Good morning. Today's topic is magnetism. One day, a shepherd, he was searching for his goat. He found out that his goat has climbed the mountain. To bring back his goat, he climbed the mountain. When he was climbing the mountain, his foot sticked to one of the stones on the mountain. With force, he tried to separate his foot, but he was unable. So he just removed his leg. He saw that his foot was not sticked, but the chapel which he wore sticked to that particular stone. Now here, he understood that when he with force removed his chapel, he saw that the leather of chapel is not sticking to the stone, but the nails which are in the chapel sticked to the stone. That stones, we call it as lodestones. We call it as lodestones. Now these stones have magnetic property, means attracting some objects, magnetic objects or magnetic materials. With these lodestones only, we prepare natural magnets, right? Now next, we also have such as magnetite, the natural magnet, magnetic oxide of iron, nothing but magnetic oxide of iron, Fe3O4. This is having the capacity or property to attract magnetic materials like iron. Natural magnets are having the property to attract magnetic materials such as iron, cobalt, steel, etc. Then, how we will form artificial magnets? There are some methods: single touch method, double touch method, rubbing a natural magnet on magnetic material can produce artificial magnets, right? Now, is magnetism produced only due to these natural magnets? No. So, natural magnets, only due to natural magnets means we can't say. Beside this natural magnet also, we can produce magnetism of greater capacity and strength compared to the magnetism produced by the natural magnets. That is, with the help of current, we can produce magnetism. Already, we are having lodestones, the natural magnets. But the capacity of these magnets is so smaller that we cannot use these magnets in all purposes. In some situations, we need the magnets which are having more capacity or more strength. There we will use artificial magnets. Now here single touch, double touch methods are one of the methods of preparing the artificial magnets. Along this electricity, the continuous change in current will also give rise to the magnetism. From that we got electromagnets. Right? Now let us discuss about this magnetism only. So first let us know what is magnet. That particular material which is having the property to attract another magnetic material. This has two poles, south pole, north pole. If like poles come closer to each other, we find repulsion. If unlike poles come closer to each other, we find attraction. Next, pole strength. Pole strength means the ability of a pole, either north or south, the ability of the pole with which it can attract or repel another pole, we call it as pole strength. Right? That pole strength is denoted with a small letter M. Now next, magnetic field. Field. So if I take any unit north pole, it has its effect up to certain extent or certain space. Arrow marks denotes the direction of magnetic field. Okay? If we bring another magnet into this field, depending upon the pole, we will find either attraction or repulsion. Right? Depending upon the pole, we find either attraction or a repulsion. So when that is out of this field, we will not find any attraction or repulsion. When this enters into the field only produced by the unit north pole, we find attraction or repulsion. Now this space surrounded by unit north pole, we call it as field or region or space up to which magnetic force is experienced. We call it as field. And such field, how we will assume means, if I take a north pole, let us think that it is moving from A to B, B to C, C to D in such a way. If we go on joining the path of this unit north pole, we find either straight lines or curved lines. So these imaginary straight lines or curved lines in a magnetic field, we call them as magnetic flux lines. We call them as magnetic flux lines. This magnetism magnetism is a vector quantity. It has magnitude as well as direction. Right? Now first, let us talk about direction. Now this is some of the flux lines, magnetic flux lines. At each angle, every point, I will draw a tangent. First, I will draw a tangent. After that, I will keep an arrowhead to this tangents. An arrowhead to this tangent. Now this arrowhead drawn to the tangent gives direction of magnetic field. Okay? Now, what about the magnitude? Magnitude means, let us assume that some number of flux lines are flowing through particular area. Now let us consider a small area in this flux line flow perpendicular to the flow. Now see, as magnitude, we will take the number of flux lines flowing through this area. How many flux lines? Now here, to the motion of magnet, we considered a area. Now, as a magnitude, we will consider how many flux lines are flowing through that area. In such a way, if these are flux lines, how many flux lines are flowing through that perpendicular area? That we take as magnitude.